In this video, we're going to derive the double angle identities. So if we come to the trig identities sheet, up to this point, we've covered the fundamental identities, which contains the quotient identities, reciprocal, Pythagorean, and even odd. We've talked about the sum and difference identities and the cofunction identities. And now in this video, we're going to derive the double angle identities. Okay, and as you can see, that they're called the double angle identities because it's like the sine of 2 times an angle, the cosine of 2 times an angle, the tangent of 2 times an angle. That's what double angle in this context means. You're taking a trig function of 2 times an angle. Okay, so if we want to figure out or come up with a formula for cosine, let's start with cosine of 2 times an angle. What we can do is we can come to the sum and difference formulas for cosine. So specifically, let's look at the sum formula for cosine, and we can write this as cosine of theta plus theta, right? So what we're going to do is we're going to use the sum formula for cosine with b equal to a, right? A and b are the same angle. All right, so expanding this out, we've got cosine theta times cosine theta minus sine theta times sine theta. Okay, so this is cosine squared theta minus sine squared theta. And there is one of the double angle identities for cosine. Now, you can also come up with a couple of extra forms for the double angle of cosine by using, so the Pythagorean identity sine squared theta plus cosine squared theta is equal to 1. We can substitute 1 minus sine squared theta for cosine squared theta. Okay, and so the result is cosine 2 theta is equal to 1 minus 2 sine squared theta. And then you could substitute 1 minus cosine squared theta for sine squared theta. So cosine squared theta minus 1 plus, so you get 2 cosine squared theta minus 1. Okay, so that's double angle identities for cosine. Now let's think about double angle identities for sine. So same process here. Sine 2 theta we can write as sine of theta plus theta. And we can write this out. So sine theta times cosine theta plus cosine theta times sine theta. Okay, but you know these are the same here, right? We can just add these up and get sine of 2 theta is equal to 2 sine theta cosine theta. Okay, now with the double angle for sine, it doesn't work out to where there's some other simple forms we could just convert this into, right? I mean, we could convert this into any kind of form. We could put reciprocal identities in here, etc. But it's different here. The Pythagorean identities are really simple, so you can substitute the Pythagorean identities in and get some other clean, simple forms. But this is really this is it for sine, the double angle for sine. All right. So now, what about the double angle for tangent? So same idea. We're going to do tangent theta plus theta, but we could consider saying that tangent 2 theta is sine 2 theta divided by cosine 2 theta. We could do that, but let's just use the sum formula for tangent. So tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. Okay, so we can see that it's going to be that tangent of 2 theta, we've got 2 tangent theta over 1 minus tangent squared theta. Okay, and similar to sine, there's not much more. We can't put it into some simple forms from this. So this is the only listed form for the double angle of tangent. All right, now, what about double angles for secant, cosecant, cotangent? Well, as I've mentioned in other videos, if you're ever wondering why only trig identities are listed for the three sine, cosine, and tangent, not the others, is because a lot of times it's because it's just trivial. In other words, so what would cotangent of 2 theta be? Well, it's just going to be 1 minus tangent squared theta over 2 tangent theta. You just flip this, the reciprocal. Right? What would cosecant of 2 theta be? Cosecant is the reciprocal of sine, so there you go. Same idea with secant. So that's why the cotangent and cosecant and secant double angles aren't listed. So, but there you go. There's the double angle identities.